talking a little bit about difference quotient. Okay, last chance for questions. Okay, so what in the homework should we talk about?
60.
What was the first homework problem? 32, so I'm in the right place here? Okay. So let me just write down some suggested problems here. 60 has been suggested. Which one? 64. 45. So we're looking for consensus. We're looking for problems where there's widespread difficulty. Other suggestions? What's that? 58? 63? I don't want to write the whole list. 61. This is almost the whole list. So maybe we can work 3 or 4 of these. So everyone vote for. You can vote for 3. Okay, so look these over. Well, everyone can vote for 3, and we'll see which get the most. You can vote for 3. $45, that was using the graphs to do composition. 57, is that next? 57 was conceptual idea of inverse. 58, idea of inverse in composition. 60, using the table to do composition and inverse. These are all good. 61, graph. 63, difference quotient, we're definitely going to hit that. 64. All right, so 63 and 64 are definites. I won't add. So 63 and 64 will do. Hold on a sec. This is a democracy. We don't just. If everyone did that, this would be mayhem, right? So 63 and 64. I won't do those exactly. I kind of had something prepared very similar to that. So we'll just, after we get done doing the other ones, we'll go through what I did, and I'm sure 63 and 64 will be no problem. So let's vote. We got 1, 2, 3, 4, 5 to go. So yeah, so vote for your 2 or 3. All right, 2 or 3. So all in favor of 60. All in favor of 60. Not so many. Okay, all in favor of 45. 45, not so many. 57, more. 58, more. 61. Okay, those 3. Are we good? 57, 58, 61, and then we'll talk about stuff just like 63 and 64. $57. So we have to draw on stuff that we've done before in the past. After Julia had driven for half an hour, she was 155 miles from Denver. After driving 2 hours, she was 260 miles from Denver. Assume that she drove at a constant speed. Let ft be the function that gives Julia's distance in miles from Denver after having driven for t hours. Okay, so this is all like Module 2 review, like setting up the function f. That's all Module 2 stuff. So that's good review. So let's do that. Determining the function f. So when we've worked in class on different things, does the graph help? How many people think graphs help when we're talking about these problems? Graphs, looking at graphs and visualizing. How many people, when you decided to come up with this, try to come up with this function f, made a graph? See? Okay. Yeah. So if it helps, use it. So what's our input or x value? Time. And then we got distance. And so we have some information. At time, 2 hours. Sorry, half an hour. 0.5. How far? 155. And then at 2 hours. How far? 260, which is not halfway, not twice as much. Okay, so we got 0.5, 155, and 262. What are the elements we're going to need to write she's driving at a constant speed? What kind of function will that be? It's a constant speed, meaning constant rate of change. So that will be what kind of function? Linear function, okay. And so what kind of things do we need to build a linear function?
Slope.
And what is slope?
Change in distance over change.
Okay, and then what is that? What is slope?
260 minus 155, which is 105.
Okay, so slope is going to be the constant rate of change. That's what the slope is. So we can find that by looking at the change of distance by the change of time. Change of distance is 105 and 1.5. Okay, and so if we wanted to do our mx plus b form, and would it be t? This would be t. So that would be our slope. What is it?
70.
It's cruise control on 70. So the question is, what's b? And so we can use this rate of change of 70 to help us. So if we're here at 0.5, 155, and we want to know then what is b. Here's our linear function. We want to know what b is. Then we can use this whole constant rate of change thing. We start with change in time is negative 0.5. How do we get the corresponding change in distance to negative 0.5? Delta D equals. So if this is a linear function, we have constant rate of change, and that means the changes are proportional. That means that the distance is always this constant multiple. The change in distance is always that constant multiple times the change in time. Change in time is negative 0.5. Gives us a change in distance of negative 35 miles. That means going back in time, half an hour, we go back 35 miles from 155, meaning our starting was 120. So that's our function that will get us distance from Denver as a function of time. And we could check it by checking these 2 points. If we plug 0.5 into that, we ought to get 155. If we plug 2 into that, we ought to get 260. Let's try 2. Plug 2 in, 140 plus 120 is 260. Okay, questions on part A. So that's review. A lot of ideas from module 2 coming in there. do this. Oh. Interpret F inverse of 500. Okay, great. Good one. So what's F inverse of 500? Tell me about the inverse function. F. What's that? She wants the input to be distance from Denver. And when you put distance from Denver into the inverse, it spits out speed? Time? What time? Time in hours. Driven. How many hours she's been driving. So then, therefore, what does F inverse of 500 represent? Is F inverse of 500, is that a time or is that a distance? The output of F inverse is time, right? So if I asked you what F inverse of 500 is, that's a time. So what time is it? It's the time. No, we do.
Oh, the time from when she started driving.
Time
In hours.
driven in hours. Is that it? When she's 500 miles from Denver. When 500 miles from Denver. Okay? Determine a rule for F inverse. So what we want is F inverse is going to input distance and give us time. Okay? So what we need to do is we need to solve for, if the output is time, then we need an equation where we say time equals something. So we can rewrite this as d equals 70t plus 120. And now we're solving for the time because time is the output now. So time would be d minus 120 over 70. Now, when we write these, we're not using d and t. That just kind of helps us get started. But the convention for input is to use x. So we want F inverse of x. But we know that x is not, no, I guess since we were using t, no, yeah, so you're using d, that's fine, we're using d, okay, sorry. D is good. F inverse of d then is, here's our rule that will give us time if we know the distance from Denver. So there's our inverse function. Construct a graph for d. So you're going to graph that rule. This is another linear function. It's 170d minus 120 over 70. I'm not going to make that graph. But if you divide both these by 70, pull it apart, that's another form of the function that will help you graph it. Is that at the end? Or is there another part?
Just the graph.
The graph. So I'll leave the graph up to you. And then we could use this rule then to find F inverse of 500. So we defined F inverse of 500 somewhere here. We said it's the time driven in hours when she's 500 miles from Denver. So how would we find the time driven in hours when she's 500 miles from Denver? Yeah, so you put the 500 into your inverse function, and it spits out the time. Okay, much more important that you listen and understand rather than, oh, I got to get my homework looking just like that, so I get my 1 point or something, or my 2 points. Make sure you're understanding what I'm saying. Question? Is there another way to do this? Because I'm wondering In terms of generating this inverse function, no, that's really it. Did you get the same function? You should have got the same function here. 70t plus 120?
No.
Well, that's the only way to write that. I mean, if you're in the mx plus b form, that's the only mx plus b form of that function. And then to get that inverse function, you're taking d equals 70t plus 120 and solving for t. So if you want to talk to me later, but yeah, there's some room for variation, but your functions, those two functions should be the same as those. Other questions on this one? Okay, can I erase? 58. Okay, on 58, we know that f and g are inverses. We know f and g are inverses, and we know that f of 2 is 23. And we know that g of 12 is 1.7. That's all we know. Do we know what f of 23 is? F of 23. Do we know that?
No.
No. We know that f of 2, if you input 2 into f, you get 23. But we don't know what happens when you input 23 into f. Okay? What about, do we know what g of 1.7 is? We don't know. The only thing we know about g is that if you input 12, you get 1.7. We also know it's the inverse process of f. So we don't know this. Do we know what f of 1.7 is?
Yes.
Do we know what f of 1.7 is?
No.
If g and f are the reverse processes of one another, if we took 1.7 and put it into f, we ought to get 12. That we know. Do we know g of 23?
Yes. 2.
The output of f, so if we put it into g, we ought to get 2. Excuse me. Yeah, I'm good. I have these little. Let's try to take its last stand against me. I'm good for like 2 hours, and then all of a sudden I have one of those. Okay. Does this make sense? Okay. So we've answered some of them. G of 23 is 2. F of 23, unknown. Okay, so if f of 23 is unknown, what about g of f of 23? If we can't know f of 23, can we know g of f of 23?
It doesn't just reverse it, so even though you know the input is 23, the output is 2.
F of 23 is some, right. F of 23 is some number. We don't know what f of 23 is. But whatever number that is, we're going to put it into g. What's g going to do? What does g do relative to f? Undoes it, reverses it. What's it going to give us? 23. So we don't know what f of 23 is. So if you just ask, what's f of 23? Who knows? But if you take that number and put it into g, now we know it's 23 because g undoes what f did to 23. Gives you back 23. Okay, so I think that's all I'll talk about on this one. That's the general idea. And there's more practice of that.
So
Yeah.
the ones that are F and G or switched, it doesn't matter because they're just gonna put it back to what it was. Right? Like
What you
us.
think about it? You got it. Other questions on this one? Which I'm not answering apparently, right? Okay.
I was gonna say, like,
What was that? What do we want to? Did we do 60?
I have a question real quick.
Yeah.
58 for G, so whenever it says, G of 1.7 is the input for F, so would it just be 1.7 for that one then?
Why?
Because if you put it in, it just reverses it.
What's G of 1.7?
It just doesn't, we don't have.
We don't know what it is. It's a number though. It's some number.
And then if you put it into F, it just reverses it, so it'd be 1.7.
Yeah. That's it. That's it. Okay. What's the next one we said we were going to do? 61? Did we say 60? I erased. Sorry. Did we say 60 or not? 61. Here's the deal with this. As x increases from 0 to 3, how does f of x change? So we look at the f of x graph. We're saying x goes from 0 to 3. What does f of x do? F of x is shown by the y value on this graph. So as x goes from 0 to 3, what does the y value do of f of x? It goes up to 3 in the first 1.5, but then it goes back down to 0. So it goes to 3, 0 to 3, back to 0.
Do you have to add, like, what did you have to, like, it went from 0 to 3 in the first 1.5?
Yeah, you want to be specific. So I'm not being specific here. You be specific, okay? As x increases from 0 to 3, how does g of f of x change? Okay, so we just said, what does f of x do? It goes from 0 to 3, but back to 0 again. So this output change of f becomes the input change of g. So where are we going to apply this 0 to 3 to 0 on the g graph? X-axis. So as x goes from 0 to 3, f of x goes from 0 to 3, but then back to 0 again. So now we're asking, what does g do when that happens? G is going to start at 9, and it's going to go down to at 6, but then the input's going to go back to 0, so it's going to go back up to 9. So that's going to go down like this. Yeah, maybe, yeah, something like that. Yep, so it's going to start at 9, go down to whatever that y value is for g, but then it's going to head back up because the input's going from 0 to 3 to 0. See, the output of f becomes the input of g, 0 to 3 to 0. And so g is saying that g goes down from 9 and then back up to 9. Okay, the rest I think you can do in 61. Sketching the graph of g of f of x, you can make some ordered pairs of g of x and f of x and make the new table. That's the one step from x to g of f of x. E?
Yeah.
2 or 3? Let's do one of these two. All right, let's do 3. So looking at, where are we going to start? What function do we start with if we're doing f of g inverse of 6? What comes first in that process? What comes first? F, G, F inverse or G inverse? G inverse, okay. We're going to do G inverse of 6. But we don't have a G inverse graph. We have a G graph. So how are we going to apply the G graph to evaluate G inverse of 6?
Is it just using the y value?
So relative to G, what is 6? What kind of thing relative to G is 6? Output or input of G? This is output of G because it's the input of G inverse. It's the output of G. And so the output of G is 6, and so then what will that G inverse of 6 be relative to G? The input of G that would give an output of 6. So where do we look for an output of 6? Y-axis on G. So is it 2? Good, because I'm running out of white space. Okay? So if you put 6, if you're looking at G, you're looking at the output, the input of G that gives an output of 6. That's what G inverse of 6 is. So it's 2. So then what are we doing? That value is 2, and this says to do f of 2. Now that hopefully is easy. We're plugging 2 into f to get the y, so it's 2.
So on the second one right there, since it's 3, which is 0,
F of 3 is 0.
so the inverse of G of 0 is, it's just 9 instead, correct?
I think it's 9. Is that right? What is 0 relative to G?
So it's the output of.
This is the output of G. We're asking what value on this graph gives an output of 0? No.
6.
The input, so this is the point 6, 0. It's the only point on this graph that has an output of G of 0. So this is the input of G that gives an output of 0, which is 6. Okay, so it's the only one of are we to the last two now? What is it called? The difference quotient?
For the answer to like A and B, you want us to say as the, f of x moves from 0 to 5, it increases to 3, and then, or we want us to say 0 to 3 to 0. Like, what would be
I
the
want you to
point?
be very specific. So just explain all the details of that, of it going from 0 to, like, when does it go from 0 to 3? When does it go from 3 to 0? Does that help? Okay, so let's look at the, so that's inverses. Okay, so I think this was the Air Force test plane function. So let's just make sure we got the input and output. What's the input of this function? X is time in minutes. Which time in minutes is it? Since the release. Time in minutes since the release. Okay? And then the output, which is f of x. It's the height, and this is above the ground, height above the ground, in thousands of feet. Really, so before you start working with we're doing lots of stuff with this function. Before you start working with it, make sure you know exactly what the input variable represents, exactly what the output variable represents. Okay, so and then I made a graph of it. You can use your graphing calculator to make the same looking graph. Okay, so here's just some warm-up. So why don't you just take a minute, the person next to you, and explain to each other what do these three numbers represent or calculate? What exactly are these three numbers? Go.
So it'd be so the whole thing goes to the height of in thousands of feet after second no. Second one is
difference of the output of that change.
The change.
Change, yeah.
Change or difference of height from 1.5 minutes to 4 minutes.
Okay, so f of 1.5 should be easy. What's f of 1.5? What is it? Who was? Go ahead.
The height above the ground, thousands of feet, 1.5 minutes since the release.
1.5 minutes after the release. It's the height of the aircraft and the test plane in thousands of feet. Good. Okay, so a little bit harder. F of 4 minus f of 1.5. And you're not allowed to say it's the difference or minus. So what, you're going to get a number when you do that whole calculation, and what does that number represent? Yeah? Yeah, go ahead. Sorry. Yeah, what's the starting time? It's not 4. You don't start at 4 minutes and go back. It's easy to, because you're reading left to right. But the starting time is going to be 1.5, right? So it's the change in height, or change in altitude, starting at 1.5, ending at f of 4. Isn't that just f of 2.5? So this very common mistake. Isn't it just f of 2.5? Do you see why it's not? This is the height at 4 minutes. This is the height at 1.5 minutes. If you subtract those values, you get the change in height over that time period. F of 2.5 is something different. What's f of 2.5? Altitude at? Which altitude? At 2.5 minutes. Totally different, right? The change in height, starting at 1.5 to 4, is a different thing than what the height of the plane was at 2.5 minutes. But this is students want to try to do this all the time. It means two different things. Okay, now what about this last thing? So we know we've got the change in height in the top. And that's the corresponding change in time. So what is this? What's that? Average rate of change? It's a constant speed, right? So if we look at how high is it at 4? This is our 4 minutes. This is at 1.5 minutes. So this is. Can we do that quick? Let's do that. This is gonna make everything move. Sorry. So what is f of 4 minus f of 1.5? Negative 1.25, and we're going to divide that by what? 1.5? No, 2.5. So we get negative 0.5. Everything back? Everything's back. We got negative 0.25. So what does that number mean? What are the units on this? Thousands of feet per minute. What does this number mean? Really important. What does that number mean? Negative 0.25. Okay. Is the height changing at a constant rate or at a changing rate? Changing rate. Is that a constant rate or a changing rate? It's just one number. It's just one number. So it's a constant rate. So how does that constant rate relate to the actual changing rate of the plane as it is descending there. What's that? It's the average. And remember what the average means? The average speed. Remember what it was? Well, we said it's a constant speed. It's the constant rate of change that would do what? It's like a different plane. It's like imagining a different plane. They both start at the same height at 1.5 minutes. What does our plane do? Well, it makes it down to a different height at 4 minutes. It kind of goes down, but then it kind of comes back up a little bit. What does this like phantom or imaginary plane do? It descends at a constant speed so that what? Yeah, at the same place at the same time. So they're going to cover the same height difference in this, reach the same altitude right at 4 minutes. Okay? So our plane kind of went down and kind of came back up. This plane goes every minute. What does it do? It goes down every minute. It goes down exactly 250 feet. There's another minute. There's another down 250. And then in the last half minute, how far does it go down? Right? Scaling factor. If for every minute we go down 250, then how far do we go down in a half a minute? Half as much. So average speed is the constant speed that gets us the same change in distance or height in the same amount of time. So our plane comes down and comes back up. This plane just slowly goes down so that at 4 minutes they reach the same altitude over that same time period. Okay, any questions? So what average speed is the constant speed to go the same distance in the same amount of time. Was our plane traveling at a constant speed? No. But that's what you get when you calculate an average speed. You get a constant speed. And it's the constant speed that does the same change in y over the same change in x as the actual, in this case, plane. Okay. So, different example. What about this? Quickly, f of k plus 1.8. These four. So interpret those four. Go. Just got 1 minute to do it, and then we'll regroup.
Function is k. Second one would equal
Sorry. Oops.
some other k is increased by the input, so k is increased by yeah.
Okay, what's f of k?
The output of function f when the input is
What is that? What is f of k? Yes, the output of function f, true, but
the altitude after the constant speed.
is it the height of the plane or the time? F of k. F of k, is it the height or the time? F of k? No, f of k is just a function value. Is it height or time? It's the height when?
K seconds. Or K minutes.
K minutes after release. It's the height, K minutes after release. That's what the function does. It takes a minutes after release and spits out the height of the plane. Okay? What about K, f of k plus 1.8? Okay, this is,
The height of the plane after.
this is really important. So if half the class all starts putting their books in their backpack, no one's gonna get it. So if we just, I'll give you some time back on another day, and just spend an extra minute here talking about this. So what's f of k plus 1.8?
The height
This is the height of the plane when?
after.
Yeah, so it's some number plus 1.8 minutes after. Yeah, so we know 1.8 minutes has gone by, plus an additional unknown amount of minutes. It's going to be the height at that time.
So it's not a change, it's a specific time.
If it's just one function value, it's not a change. It's a height. It's an output of the function, which is a height, exactly. A height of the plane at that time, k plus 1.8. What about the next one? Is that a height or a change in height?
It's a change in height.
Over what time period? How long is the time period that we're going to see the change in height?
From K to 1.8 plus K.
Is the time period 1.8 minutes long or k minutes long?
1.8.
Ascension in the ranks. So we're starting at k, whatever k is. And we're going to k plus 1.8.
So it's from K to K plus.
That's right. And how long of an interval is that? 1.8. So this is going to be the change in height. The change in height. So here's f of k. And then this is going to be f of k plus 1.8. So if we subtract, we get the change in height over a 1.8 minute period starting at k. The change in height over a 1.8 minute period starting at k. Okay? Then what will happen if we divide by 1.8? That's right. It'll be the average rate, which will be a constant rate. I gotta turn it on. What should we use? Use red. So we can start k at any time. So this is showing that you can start k at any time you want. And what will you get for the chosen value of k? You'll get the constant rate that will result in the same change in height over the next 1.8 seconds, no matter what k you start at. Oh, that's not where you do the cursor. So no matter where you start k, this will generate the constant rate that will get the same change in height over the next 1.8 minutes. Okay, email me if you have issues or questions, but your exam is tomorrow. Bring your homework on Friday. The earliest would be 40 minutes. 40 minutes after. So maybe there's one. I don't know. There might not be. You'd have at least half an hour.
I came from your office. Are you going to be in the pathways in the hall
Tomorrow? I might not even be on campus tomorrow, so you can email me. No, I do have to come in there. When are you going to take the test?
I personally don't have anything.
Actually, I'm in the testing center at 2. Yeah, that's my time to be in the testing center, so I'll have to meet you a little bit before that if you want. Yeah. So like early afternoon.
I forgot my calculator.
I forgot it too, so it's in my office. So.
Okay.
Thank you very much.
Sorry about that.
Okay.
I have a bunch of stickers.
Okay, so that's fine. From here on out, I don't take anything late. This will just be your question, but.
I'm sure I'll come playing on Friday.
Probably.
Yeah.
Together.
Yes.
Okay.
Yeah. Yeah.
Because I was telling her that this is true that proportional. I understand proportionality in my head, but when it comes to
Well, but that was a really important thing we talked about.
I
are
know.
Two quantities being proportional versus the changes in the
Right,
quantities
right.
being proportional.
No, when quantities are proportional, are the changes by default always also proportional? Or
That's true. If changes are proportional, are the quantities proportional by default? No.
Right.
That's like a linear function. You can have a linear function, all linear functions, the changes are proportional, but not every linear function. The quantities are proportional, like a function with a negative rate of change. Changes are proportional, but the quantities are not.
So say that I wanted to check to see if this was proportional. You don't have to do it for me, just like what degree do you have to
Well, you're comparing x values and corresponding y values. So I would make a table. Yeah, a table of values is the best way to check proportionality. Does that help?
Yeah.
Okay.
So yesterday the tutor was explaining this problem to me. If you put in 0 for
Uh-huh.
it's corresponding y would be 3. So it's
Well, it's 0 or 3. F of x is 0. X is 0 or 3. I don't know why were they doing that?
I don't know,
You
she-
said as x increases from 0 to 3, so you're monitoring the.
yeah, she said to complete, like, it had nothing to do with this, like, at all. She said, like, if you plug in.
Oh no, that's completely wrong.
Great. Okay.
X is changing. It's taking on every value from 0 to 3. It's not just the beginning and the end.
Right.
X changes from 0 to 3. It takes on every value from 0 to 3. So you're asking what this graph then indicates what y values will be taken on as x goes from 0 to 3.
Okay. Like, it makes sense when you were saying it, but I was just like, I didn't know if that was like
No.
another. So
No,
okay.
the
Just
graph
ignore
is
that.
completely important because it's telling you what the y values do as x goes from 0 to 3.
Okay.
Yeah,
Alright.
so
I'll
I
just
would
look up.
avoid that tutor in the future.
Great.
Yeah.
Yeah.
The one just for 1 second. Is it in there?
Oh, yeah, I got
Oh, goodness, that one. Like, the one that's over in the example, one of them had the exact same answer.
Oh, yes, I don't know.
Yeah, I was just like,
I would rather.
Well, I mean, all I can speak to is, was the way yours was graded accurate, you know? And if someone else wants to come to me and show me theirs and say it was incorrect, but if you want to sit down and look at individual problems, then
So,
it's a grader. I have a grader.
so he graded, they're graded.
They grade every single person's, they have a rubric and they'll grade it the same for everybody.
And I don't understand how, like, I could get the same answers as the person I work with, if I get a lower score.
What I'm telling you is, I don't know about the other person. If you want to sit down and if you're contesting your score, I'm happy to sit down and go over the things that you missed and see if that was accurately graded. So, you know, it could be that that person deserves a lower score. That doesn't affect you, you know?
No, I know, I just like,
But I'm happy to go over that with you and go over the things you missed and figure out if the grading was right.
Alright.
I'm happy to do that.
Hello. We've probably gone over this, or you have or something, but is there any way to get the textbook that's online in a hard copy? Or, because there's no way to print it, and then I was like, oh, I'll try to do the print screen, and then I tried to do the print screen,
Let me just I'll send
Yeah.
an email right now.
but the cursor like moves when I try to do the print screen, and I just can't read off of it.
Okay, cool. Very good.
There's gotta be something for somebody with like disabilities or something, I don't know. Because I'll print it out, it's just, you know. So, an email with the,
I'm going to email the person who would know the answer.
oh, okay. Yeah,
That would be Karen Burgermeister. 70 hard text. There a current version of the online Okay, so, no.
Yeah,
Mm-mm.
because they definitely didn't let me do that.
What's your name, or what's your email address?
Jenna, Jenna,
Okay,
N is in Nancy, M is in Mary, 84@hotmail.
Jenna NM. Here, come look at this. Jenna NM
84
84.
at Hotmail.
Okay, so I'm copying you on that email,
Okay.
and I'll just say please reply all. Okay,
Thank you.
see what she says.
I just had a quick question about the inverse of
Yeah, sure.
on Monday. So I was trying to do the homework yesterday on the f-1 with 500.
F
And I,
inverse.
yeah. And so I was just wondering, is it just that you in your head change it to kind of x and y and then switch those?
So it's the reverse process. So what before was the output of F corresponds to or becomes like the input of F inverse.
Okay.
So if it's the reverse, process, like turning the machine going backwards within the machine. So
Okay, backwards.
yeah, so then outputs and inputs are switched, right? So if you turn the machine backwards, now your input is coming in through the bottom, which was the output of F, and then the output now is what was the input of F.
Okay.
So if you had F of if F of 3 equals 4, then what statement could you write concerning the
So inverse.
F inverse of 4?
equals 3?
Right.
Okay.
That's the basic idea.
And then for when you're looking at it on the graph.
But now, so if you have like quantities associated with this, like area of floor space and
Yeah.
time, well then those get switched.
As well.
Oh yeah,
Okay.
because so if this was area of floor space, and this was cost, okay, then what kind of thing goes into the F inverse function? What does the F inverse function do then?
It shows the it takes the cost and puts out the area.
It takes the cost and gives you the corresponding area.
So it's
It's the reverse.
quantity name stays with the number it's with.
Oh, of course, yeah,
Okay.
yeah. If that's the quantity 3 and it represents area,
Okay.
then
And
that's
then-
area, and then yeah.
On a graph, so that the